Hi everyone, today we're starting our Unit 5, which is about the Pythagorean theorem. Now, Unit 5 is made up of a lot of different modules and a lot of different lessons. So the first lesson of Unit 5 is from Module 2, Lessons 15 and 16. Lesson 15 is the informal proof of the Pythagorean theorem. Now, we're not actually going to do a proof in this video, but we will be doing one in class, so this is just to kind of get us warmed up for that idea. So the first objective for today is that students are introduced to the Pythagorean theorem and will be shown an informal proof. Our second objective says students will use the Pythagorean theorem to find the length of the hypotenuse of a right triangle. Now, the hypotenuse is the side length that is opposite of the right angle of a right triangle. So when we look at the visual, that'll be much clearer in terms of identifying the hypotenuse. So let's talk about the Pythagorean theorem. It is a mathematical theorem, so it has a formal description. The Pythagorean theorem says if the lengths of the legs of a right triangle, so again, this only works for right triangles, are A and B. So we're just labeling the legs of a right triangle A and B, and the length of the hypotenuse is C, so we're just naming it C, then A squared plus B squared equals C squared. Now, I'm sure you've heard this formula before, but you didn't know what it meant. You didn't know what it was called. You didn't know where it came from. So again, if I have this right triangle, I have three sides, A, B, and C. C always being the hypotenuse, which is the side across from that right angle, and A and B being the legs. Then the Pythagorean theorem says A squared plus B squared equals C squared. Something we may need to go over is the idea of squaring a number. So we're going to look at a couple examples where we do some solving. Make sure that you're really paying attention to where we square these numbers. So Pythagorean theorem says A squared plus B squared equals C squared. I'm given an A and a B, so I'm going to substitute those numbers. 6 squared plus 8 squared equals C squared. When I square 6, for example, 6 times 6 is 36. I square 8, 8 times 8 is 64. And then I add those two numbers together, so I get 100 equals C squared. In order to remove the squared from that C, I take the square root, which I punch into my calculator, and I get the value 10 equals C. Module 2, Lesson 16 is about the application of the Pythagorean theorem, which means we can use this an awful lot in the real world. So students are going to use the Pythagorean theorem to determine missing side lengths of right triangles. And that can be right triangles like a picture, like we normally see, or right triangles we find in the real world. So the first example we're going to do is just a basic right triangle. It has one leg with a length of 5, a hypotenuse with a length of 13, and another leg that we do not know the length of. So I'm going to substitute my value B and C, square those numbers, balance the equation, so I have A squared is equal to 144, take the square root, and A is equal to 12. Example 2 is the same scenario, but let's think we had a ladder leaning against a building, and the base of that ladder was 5 feet from the building, And I want to know how high on the wall will my ladder touch. So again, this is the same problem. I know one leg and I know the hypotenuse. I'm just looking at it in the context of the real world.